All right, welcome to section 5.1. This is chapter 5, and we are working our way towards solving polynomial equations, so equations that are bigger than quadratic, cubics, quartics, and so forth. To do that, we are going to use our properties of quadratics. We're not going to get rid of those. But to help us, we're going to study a little bit more some properties of exponents. You've seen these before in Algebra 1. And we've actually utilized some of them already in Algebra 2, but we're going to formally introduce them right here. So the first property says if I'm multiplying two powers that both have the same base, I'm allowed to add the exponent. Okay, so I have a to the m times a to the n, so I'm allowed to add the exponents. Two things to note, on all of these you need to be talking about the same base. Right, notice this isn't a b here, right? It's got to be the same number. And the other thing to notice about this first property is it's not addition. Okay, we have no rule that says a to the mth power plus a to the nth power. There's no rule that lets us do anything there. Okay. The next rule is a power of a power rule. So if I have a to the mth power, all to the nth power, we're allowed to multiply the exponents. Likewise, if I have a power here where I have a times b all to the mth power, the m, it's not truly distribution, but it's kind of like it, right, where the m gets applied to everything inside here. Okay, so if this had three terms, a times b times c, the m would get applied to all three things. Okay, so it's kind of like distribution, but not officially distribution. The next property is the negative exponents. Okay, so a negative exponent tells us how many times we're going to divide a number by itself. And the easiest way to work with negative exponents is to conceive of it as a fraction, to conceive of the base as a fraction. So this is a over 1. And now, to get rid of the negative exponent, I simply take this a that was in the numerator and I shift it down to the denominator, and now the exponent becomes positive. Likewise, if I had a to the negative m in the denominator, I could shift it up to the numerator, and now it would become positive. It would be a to the positive mth power. Okay. A to the 0th is 1. There is a reason, but it's kind of a definitional piece. We have this property where a to the mth divided by a to the n. Again, same base. We're allowed to subtract the exponents. And lastly, this power of quotient is similar to this guy, power of product. A divided by b, all to the nth power, is a to the m divided by b to the nth power. Okay. So these are the properties that we're going to take with us. We're going to utilize these as we try to simplify expressions. Okay. And so here are a few expressions. We're just going to rely on those basic properties to help us go through each one of these examples. So if for some reason you find yourself having forgotten the properties, I want you to see that you can still figure out these answers. Okay. So the first thing is, let's talk about what the property says here. It says I'm allowed to multiply the exponents, and so this should be 6 to the 6th power. Okay, and that's just one of the properties we saw in the last slide. Right, we just multiplied 2 times 3. But let's say you forgot that rule. Well, what does 6 squared cubed mean? It means 6 squared times 6 squared times 6 squared. And now the first property on the last screen said, well, here you're just allowed to add the exponents up, and so it gives us 6 to the 6th power. Okay. So I want you to see that, yes, we have these rules, but these rules are just a consequence of understanding what exponents mean. Okay. 4 to the 5th divided by 4 cubed. Again, we saw a rule on the previous slide that said we're allowed to subtract here. So this is 4 to the 5 minus 3 power, or 4 squared. Okay. 4 squared. Again, if you find yourself doubting that rule or forgetting that rule, remember that 4 to the 5th power is this divided by 4 cubed, which is that. And now our general rules of canceling say, these are going to cancel, these are going to cancel, these are going to cancel, and it leaves me with 4 times 4, or 4 squared. Okay. This last one, 7 to the negative fourth. Again, a negative exponent tells us how many times we're going to divide a number by itself. And the easiest way to conceive of this is to write it as a fraction, 7 over 1. And now the negative exponent takes the base and moves it. So in this case, it moves it from the numerator to the denominator. So this is 1 over 7 to the fourth power. A few things to note. Number one, a negative exponent does not mean a negative number. Okay, this 7 is not negative. Right? This 7 is not negative anywhere. This is a positive number. It just means it's being divided and not multiplied. Okay? So that's the first thing to see. The second thing is you're never allowed to leave a negative exponent in your answer. Okay? So your answer, whatever the question was, should never have a negative exponent in it. Okay? So we always need to simplify to get to that point. Okay? Okay, so these are a little bit more complicated examples. Again, just integrating these properties that we saw at the very beginning of this lesson. We're just going to apply them piece by piece. Okay, so I'll do the first two, and then I'll have a few problems for you guys to do as we proceed. Okay. So the first thing I see is I have a product here, all to a power. So the rule says I'm to bring the 3 into every piece. Okay, it's kind of like distribution, but not really. All right, so this is going to be x to the 5th, and that's going to get cubed, and we're going to get y squared, and that's going to get cubed. Okay, all over x to the 15th, y to the 8th. Okay. Now, x to the 5th cubed, we have another rule now that says we're allowed to multiply those exponents, and so that's going to give us x to the 15th, y to the 6th, all over x to the 15th, y to the 8th. Okay. And now we try to simplify as best we can. I see x to the 15th on top, x to the 15th on bottom. Those cancel out, and that's going to leave y to the 6th over y to the 8th. So let's cancel those out. And now I can simplify those either using my subtraction rule, right, or I can visualize and say, well, y to the 6th, what does that mean? It means I'm going to take y times y times y times y times y times y. Right, so I have y being multiplied by itself 6 times, and I have y being, on the bottom, I have y being multiplied by itself 8 times. So there are more y's that are on the bottom, and I expect 6 of the y's to be able to cancel out. So this should just leave us 1 over y squared. Now, if you don't like that, again, the property says you can take y to the 6th minus 8, which gives us y to the negative 2nd. Of course, y to the negative 2nd is 1 over y squared. Okay, 1 over y squared. Okay, so going back to where we were just a step before, the x to the 15th cancel out, leaves us y to the 6th over y to the 8th. And that simplifies farther to 1 over y squared. You can either think of it as, an expanded, what does y to the 6th over y to the 8th actually mean? Or you can use the property 6 minus 8 is negative 2, y to the negative 2nd power is 1 over y squared. Okay. Either way to think of it is fine. Okay, here in example B, we have a to the negative 4th over b squared, all of that being squared. So again, this property, this 2, comes in to both pieces, both the numerator and the denominator. So it gives us a to the negative 4th squared over b squared squared. A to the negative 4th squared is a to the negative 8th. B squared squared is b to the 4th. And now we're not allowed to leave an answer with a negative exponent, and so we need to take the a to the negative 8th, and we need to deal with that. Again, this a is positive, its exponent is negative, and so to deal with the negative exponent, we basically just take this power and shift it to the denominator, and then it becomes positive. And so now I need something in the numerator kind of as a placeholder just to say there was a numerator, and so we throw in a 1 just as a way of saying there's something in the numerator, just 1. Okay? So these are the level of problems that you should expect out of Algebra 2, maybe even a little bit more. Okay. All right, so here are 2 problems I'd like you to work on. If you're watching the video at home, go ahead and pause the video now, and please work through these 2 examples. And when you resume, we'll go through the answers. For my live studio audience, go ahead and start working on them. All right, so let's look through these 2 problems. So the first one, we have a product here, and we're going to go ahead and bring the 7 into every piece here. This becomes especially important on the next example where we need to bring the 3 in and hit the -2 to the 3rd power. Usually students struggle to remember that piece. Okay. So this becomes x squared to the 7th power, y to the -6th, also to the 7th power. So this is x to the 14th, and this is y to the -42nd. We're not allowed to leave our answer with a negative exponent, so we just create a fraction, consider this all over 1. And so to finish this off, x to the 14th over y to the 42nd. Now, it may look like you could simplify this farther, but since these are different bases, right, x's and y's, there's nothing that you're allowed to do there, right? None of the properties allow you to simplify through different bases. Okay, so if the base is different, you're done. On the next example, again, we're going to bring the 3, the exponent of 3, into both the numerator and denominator. And so I'll write it first like this. So this is just the numerator cubed, and this will just be the denominator cubed. By the way, it may have been easier to actually simplify first before I keep going this direction. Had I looked at this guy and said, well, wait, this is just b divided by b, simplify that to begin with. So actually, let me start over. And let's try to simplify first. I think it'll make our lives a little easier. Right, so b divided by b is just 1. It's gone. And I have a squared over a to the 5th. So that should be -2 in the top, and then a cubed in the bottom, and all this to the 3rd power. All right, so -2 in the top. It's still there. And then a squared divided by a to the 5th. Right? A squared divided by a to the 5th is just 1 over a cubed in the bottom. And now I'm going to take this to the 3rd power. All right, so -2 to the 3rd power is -8. A cubed to the 3rd power is a to the 9th power. And again, we can't go any farther. Just a note of clarification. Remember, and it's not in this problem, but remember, a negative exponent doesn't make a number negative. Number 2, you're not allowed to leave a negative exponent in an answer. But number 3, if the number is negative, of course you have to have that negative sign there. Okay, so students, after looking at negative exponents and negative numbers, tend to get the things mixed together. Okay, so I want to make sure you keep those straight. A negative exponent means we're dividing the number. A negative number means it's smaller than 0. Okay, smaller than 0. All right, so there's one other idea in this section. It is the idea of scientific notation. Scientific notation. Again, this is belabored in our science classes, in our Algebra 1 class, probably in middle school. I don't intend to do that. Just as a reintroduction, scientific notation says we're going to write a number in the form c times 10 to the nth power, where c has to be a number between 1 and less than 10. Okay. It basically means I can only have a 1-digit number and then a decimal times 10 to the nth power, right? So there can only be one number in front of the decimal place for scientific notation. One other point to know, on your calculators, you'll sometimes see this, 3.5 e to the -4th. This is the way your calculator shows scientific notation. Just means 3.5 times 10 to the -4th power. And of course, that would mean we're going to move the decimal 4 places this way. So if I had 3.5, I go 1, 2, 3, 4, and now the decimal's there. And that's our new number. Okay, so scientific notation just tells us basically how many times we're moving the decimal. It is very useful when we're talking about really, really small numbers at the microscopic atomic level. It's really useful when we're talking about very large numbers, the astronomical measures. They're just massive. Usually when we talk about money, we get there by using units. We don't refer to money often in scientific notation. We just talk about it in billions or trillions of dollars. And again, it's a way for us to shorten numbers. We don't want to have to write a whole bunch of zeros. That's the point. And so here we have a swarm of locusts in a square kilometer, 85 million of them. You think on that for a minute. I don't know if this is true or not, but that'd be a lot of locusts. And we have an area of 1,200 square kilometers. Question, how many locusts? So this is nothing more than multiplication, and I think most of your calculators would handle, doing 85 billion times 1,200 quite easily. But if we want to conceive of this in scientific notation, this would be 8.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 10 to the 7th, times 1.2 times 10 to the 3rd. And now if we think of this using the commutative property and just switch the order here, I get 8.5 times 1.2 times 10 to the 7th times 10 to the 3rd. And this is why this is in this section, is because 10 to the 7th times 10 to the 3rd is just 10 to the 10th. Right? So that's the whole reason this is in this section. And 8.5 times 1.2, will someone help me out with that? What is that? 8.5 times 1.2 is 10.2. 10.2, and so now I can see that that's still a lot of locusts, right? And being able to do 10 to the 10th power gives us a ballpark idea of how big that number is, and it saves us from having to work with a whole bunch of zeros that we wouldn't need to work with. However, there's one issue with that number, right? That number is not in scientific notation, and so we need to assume that we wanted a number in scientific notation, but that number is not in scientific notation. All right, so why is it not? Because scientific notation says you're not allowed to have a 2-digit number in front of the decimal, so we simply modify the number to make it a 1 number in front of the decimal, so 1.02 times 10, but now it's not going to be times 10 to the 10th because I just changed the number. So I moved the decimal 1 spot, so it's either going to be times 10 to the 11th or times 10 to the 9th. And unfortunately, I don't have an easy way to remember how to do that. So all I do is I come back to the original number and I say, well, look, I was supposed to move the decimal 10 spots from here to the right. Right? That's what 10 to the 10th means. I'm going to move this decimal 10 spots to the right this way. So to get that same number back, I'm now starting 1 unit farther away. Right? Instead of starting here, I'm starting a unit farther away, so I need to make up for it by moving 1 more unit back. Okay, so 10 to the 11th power. Namely, the extra 1 gets me back to where I started, and now I need to go 10 more spots over. Okay. I would tell you to think through it just like that, because it depends if the exponent is positive, we're talking about a really big number, or if the exponent is negative and we're talking about a really small number. So instead of worrying about rules and trying to memorize exactly how it works, I would tell you just work it through. 10 to the 10th means I'm supposed to move this way 10 units, but I'm starting 1 unit farther away, therefore I need to go an extra unit that way. Okay, and so that's the extent of scientific notation. I don't plan on stressing it much in this chapter. Okay, great, and that concludes section 5.1. Thanks for your attention.